Welcome to this explainer. Today we're tackling one of the absolute wildest paradoxes in all of winemaking. We're going to dive right into how a totally common microbiological accident, something that would normally completely wreck a batch of wine, actually goes on to create some of the most incredibly complex and highly sought-after wines on the planet.
So, what happens when a wine goes bad? Well, picture this for a second. Imagine you're a winemaker. You walk down into your cellar, pop open a wooden barrel to check on your aging wine, and instead of seeing this pristine, beautiful liquid, you find a weird, whitish, powdery veil just completely covering the surface. Now, for most winemakers throughout history, this is an absolute nightmare. It means the wine was stored in barrels that weren't totally full, the alcohol was too low, and it got exposed to the air. Usually, that means the whole batch is ruined.
But here is the kicker. And this is the amazing paradox we're unpacking today. In certain pockets of the world, this exact accident isn't a disaster. It's actually a cultivated, highly guarded miracle. Instead of destroying the wine, this mysterious veil completely transforms it, basically unlocking flavors that you literally cannot get any other way.
Moving into Section 1, the science of the veil, microscopic magic.
So what is this stuff? It's called the flor veil, or just flor, which means flower. It's a powdery, whitish film made up of native yeasts, specifically strains like Saccharomyces cerevisiae, that are just naturally hanging out in the local ecosystem. Now, normally, after primary fermentation finishes and the sugars are depleted, regular yeasts just die off. But these flor yeasts, they're survivors. They manage to stay alive by feeding on the wine's ethanol, along with whatever residual sugars and acetic acid are left behind. The way this phase shift happens is honestly like a biological sci-fi movie. At first, these yeasts are completely submerged in the liquid, doing their regular fermentation thing. But as the alcohol level creeps up to around 11 or 12.5%, the environment gets super hostile. So to survive, the yeasts form this protective biofilm around their cells. This actually makes them lose density, they get lighter, and they literally float to the surface of the wine. Once they hit the top, they clump together into these flower-like shapes and switch into a respiratory phase, just breathing the oxygen trapped in the barrel. The catch, though, is that these yeasts are incredibly high maintenance. They need a perfect Goldilocks environment to survive. Temperatures have to be mild, right around 18 to 20 degrees Celsius, which is why flor always peaks in the spring and autumn. They need really high humidity, and crucially, they need oxygen, which means winemakers deliberately leave the casks unsealed with an air gap at the top. On top of all that, the alcohol content has to be perfectly dialed in. It needs to be above 15% to kill off bad bacteria. But if it ticks past 17%, the flor yeasts themselves will die. Talk about a delicate balance. When this thick veil successfully forms across the entire surface, it becomes a physical shield. It completely blocks any oxygen from touching the wine underneath, creating a totally anaerobic environment. So the wine doesn't oxidize. It doesn't turn brown. Instead, the flor yeasts drink up that surface oxygen and use it to transform the alcohol into a chemical compound called acetaldehyde. And let me tell you, acetaldehyde is the absolute secret sauce behind the intense, really pungent aroma that these wines are famous for.
Let's move to Section 2, Montilla and Jerez, the biological giants.
First up is the denomination of origin Montilla-Moriles down in Córdoba, Spain. This region is all about the Pedro Ximénez grape. The climate here is scorching hot and super dry, so winemakers lay the harvested grapes out on these special drying racks called paceras to bake right in the sun. Because the Pedro Ximénez grape builds up such a massive amount of natural sugar in that intense heat, the resulting wine naturally ferments straight to that magical 15% alcohol mark. They don't even have to artificially fortify it for the flor to thrive.
Now contrast that with the legendary Jerez triangle, the home of sherry. Over there, they use a totally different grape, the Palomino Fino. It grows perfectly in their chalky, moisture-retaining Albariza soils. But Palomino naturally ferments to a much lower alcohol level. So to hit that safe zone where the flor can actually bloom, winemakers in Jerez step in and manually fortify their base wine up to that 15 to 17% sweet spot by adding grape spirit.
This whole divergence in the biological process is exactly what creates the different styles of wine you see on the shelf. Fino and Manzanilla go through pure biological aging. The veil stays perfectly intact for years, which keeps the wine super pale, dry, and light. But then you have these beautifully complex styles like Amontillado and Palo Cortado. With these, the flor veil is either intentionally killed off with more alcohol or it just naturally dies over time.
And once that veil is gone, boom, the wine is exposed to oxygen, it goes through oxidative aging, turning a rich amber or mahogany color and picking up these incredibly deep, woody flavors.
I really have to single out Montilla here, because it's just so unique. Montilla is technically a Fino, but legally it can only be aged in one very specific town, Sanlúcar de Barrameda, right where the Guadalquivir River hits the ocean. The microclimate there is so perfectly humid and cool that the flor veil doesn't just peak in the spring and fall, it thrives, thick and healthy, 365 days a year. That constant year-round protection gives Montilla a remarkably pale, subtle profile with a really famous distinct aroma of chamomile.
On to Section 3, Huelva and Huera, Spain's hidden gems. So, over in the Condado de Huelva, they've been at this since the 14th century. Actually, fun fact, these were the exact wines loaded onto Christopher Columbus's ships heading to the New World. Today, a massive 86% of their vineyards are planted with a rugged indigenous grape called Zalima. It's incredibly tough. It even naturally resisted the devastating phylloxera plague in the early 1900s. Winemakers use it to craft Condado Pau, which is this dry, biologically aged wine kept under flor in American oak casks. It's got a super elegant, slightly bitter finish that is just fantastic. And then we've got Huera. Now, Huera is up at a high altitude with an extreme continental climate. We're talking freezing bitter winters and absolutely scorching summers. Here they take the native Verdejo grape and blend it with Palomino Fino to make a wine categorized as pale white. By law, this fortified wine has to spend a minimum of 3 full years aging biologically under the flor veil in oak barrels before it ever hits a shelf. The result? This wild, totally fascinating blend of herbal notes mixed with rich bakery aromas.
Section 4. Global Flor Wines, Beyond Spain's Borders.
What I find absolutely fascinating is how this exact same biological phenomenon happens globally with completely different native grapes. In France, they're using the Savagnin grape. Deep in the underground cellars of Hungary's Tokaji region, the natural humidity lets the ferment grape grow a flor veil for their dry Samaroni wines. And down in Sardinia, Italy, they use the Vernaccia grape to make this gorgeous amber-colored wine that just bursts with the aroma of almond blossoms.
France's Jura region actually takes things to a whole new extreme. They call their veil the voile. Now, unlike the Spanish systems where they are constantly blending younger wine with older wine to feed the yeasts, Jura winemakers use static vintage aging. They put the wine in a barrel and literally do not touch it. They don't rack it, they don't top it up, nothing. For 6 entire years. Because of evaporation, a huge chunk of that wine just disappears into the air. What's left gets bottled in a very specific, weirdly sized 62 centiliter bottle called a clavelin. Why 62 centiliters? Because that represents the exact mathematical proportion of wine left over from 1 liter after 6 years of evaporating under the veil.
Finally, Section 5. The payoff in the glass. Tasting the life cycle. At the end of the day, when you're tasting a flor-aged wine, you are quite literally tasting the life cycle of the yeast. See, when those flor yeasts finally run out of nutrients, they die off and sink right to the bottom of the cask. That triggers a process known as autolysis, where the dead yeast cells start to break down and release proteins and polysaccharides straight into the liquid. That right there is what gives the wine those crazy, unmistakable notes of fresh-baked bread, yeast, and toasted almonds. You get these wild herbs, a salty, slightly bitter finish, and, if it hasn't oxidized, a stunningly pale color. So, if you take anything away from this explainer, let it be this. When you get a glass of this vibrant, incredibly aromatic wine that somehow feels entirely light on the palate, it didn't just happen by luck. It is the miraculous, highly deliberate result of generations of winemakers figuring out how to tame what everyone else thought was a biological hazard. Which leaves us with a pretty profound realization. These wines totally challenge our understanding of what we're actually drinking. When you get that hit of toasted almond or fresh bread, are those flavors really coming from the sun, the soil, and the fruit? Or are they a chemical message left behind by millions of microscopic organisms that fought tooth and nail to survive in a hostile wooden barrel? The next time you raise a glass of Fino or Manzanilla, you gotta ask yourself, are you tasting the grape or are you tasting the surviving yeast? Thanks so much for joining me on this explainer, and keep exploring the amazing science hiding right inside your glass.